So, hey Alvaro, how are you doing?
Hello, I'm doing very well. Thank you.
How warm is it in Spain right now?
Well, I can tell you, I was just riding here the bike to the office.
Hmm.
I would say not very warm. It's a few degrees, I would say, Celsius.
A few degrees, okay, below 10?
Yeah, like 2 or 3.
Oh, okay, but because you look like 25, I mean, say, okay, this is like, Hawaii feeling there.
Sun is strong in Spain. That is no question. When there's no sun, the temperature can drop. Here in Madrid, we are 600 meter above the sea level,
Hmm.
so it's a bit high. That's why it gets colder, and we have
Hmm.
a lot of thermic variation between day and night. It will get maybe to 10, 15 during the day, but it gets
Okay.
below zero during the night.
Hmm. Okay, the last time we talked about Postgres contributions, JDBC, and
Hmm.
and your contributions and open source contribution and forks. And today the plan was to talk about Stackgres.
Okay, my pleasure.
So I hope this was the plan. So I think we said Stackgres is something else, but Stackgres is nice. And for me, I took a brief look at Stackgres. Looks interesting. For me, the Stackgres is something like a database cloud. This is the short explanation I would give. It seems like a complete solution to run Postgres on any cloud you like. Is it a correct one?
I love to hear others define our products and software, and I think
Hmm.
you did a really good job. I like
Hmm.
I like the term. I may borrow it if you don't mind.
Yeah, sure, sure. You give me your credit card later, but for now,
Yeah.
right? So the first sponsored episode of AXFM. But um, and what I like about your solution, I think this is the view times where I can see that Kubernetes is the right thing to do, because this is a product, and
Mhm.
the Kubernetes defines a specification and API, and
Yeah.
and now you are able, if you do it correctly, to run everywhere your product, which
Yeah.
for me makes absolute sense because you would like to be available, everywhere, and not only on major platforms, right? So I would say the Kubernetes is just the perfect solution for product like Stackgres. This is how I would even say maybe there is even no other way to do it except maybe bare metal. If you try, I don't know, even you would have to have operating system, whatever. So I think without Kubernetes, so what would be the let's say Kubernetes dies tomorrow? Is the another is it another alternative to run such to do a Stackgres on something different right now?
Yes, I think there are, but let me get there in a few moments. I think you touched on a few topics that are quite interesting. I would like to briefly elaborate, and again, your definition was great. And by the way, I'm very happy to be here for the third time with you. I really appreciate this having this opportunity. So, you said it's a database cloud. I love this term. Really, it's great. Never occurred to me before, and it defines very well what it is. So it's just a platform. It's a fully featured. I would say it's a very complete platform to run Postgres anywhere. Right? It
Hmm.
has everything that you need to run Postgres. It contains the features that are, as of today, let's say table stakes to run Postgres or any database. It comes with integrated connection pooling, high availability, monitoring, managed backups, customized configurations. Like, what is
Hmm.
table stakes? Like, nobody would ever run anything without all these things in production, right? But then
Hmm.
on top of that comes with a lot of automation and tools to make your life very simple while retaining production quality. Because as we mentioned last time, Postgres, I said, is kind of not batteries included. It's installing for development environment is trivial with a Docker container or with apt-get install whatever, but running production is a totally different story, and there's a huge gap. So Stackgres covers this gap and gives you a fully contained, fully featured platform that helps you run a Postgres environment with everything that you need. Sometimes I'll say it's kind of a GitLab for Postgres because it's fully complete, contains everything that you need. Now, it's very
And what I'm
interesting.
also assuming is, because you touched on this briefly, so one of your how to call it services to the community is you are providing so Ongres provides best practices for Postgres. So what we talked about the last time, that you
Yeah.
can create a configuration for Postgres, which is a conventional, which means okay, this is like a production configuration. What I'm assuming, Stackgres also does that. So if you install the Postgres on with Stackgres, you get the best practices built in, right? as a default.
Absolutely. For example, Postgres is a database that we mentioned last time, right? That you should have a connection pooler in front of it. And Stackgres just comes with connection pooling included. You can disable it, but by default, it will run with a connection pooler with PG Bouncer right in front. Postgres has around 300 configuration parameters, and it's hard to know how to tune all of them or which ones to tune. Actually, nobody tunes 300, but 40, 50, it's doable for a production database carefully tweaked. And who knows how to tweak all these parameters. We actually built a website for tuning Postgres parameters, which is free for anyone to use for the community. It's called, so the Postgres configuration file is called postgresql.conf. This website is postgresql.co.nf. So just basically shift the dot 2 positions to the right. And we took obviously all these learnings and default configurations for Postgres in Stackgres. They're also tuned, of course, for a generic workload, but they're quite tuned. So definitely we enforce all these best practices, and we turn it into a batteries included. So if Postgres by itself is not batteries included, with Stackgres it is definitely batteries included.
So it's like conventional Postgres, right? This is like Postgres with
it just uses vanilla Postgres, right? Now, what is interesting, you mentioned that thanks to Kubernetes it can be done, and you were questioning whether it would be possible to do without Kubernetes, and both topics are very, very interesting. So let me elaborate here a bit. Kubernetes, from my understanding, the way I define Kubernetes is an abstraction layer over infrastructure, which is programmable. So it's programmable infrastructure abstraction. Here we Java guys love abstractions, right? Don't we? So this is what it is. It's an interface. Well, it's an API, right? And towards this API, I can create, manage compute, I can create, manage networks, and I can create and manage storage. And the Postgres cluster, the unit of a cluster is more than one node, typically, right? Typically, we'll have your primary and several replicas that you can need for high availability purposes and for read scaling. So how to manage all that in a uniform way? Actually, let me briefly go back on how we started Stackgres and why we did Stackgres. We didn't do Stackgres because Postgres on Kubernetes was the best next thing, or because there was a trend at the time to start doing things on Kubernetes, or to complete your portfolio so you can also have an answer for those who want to run database on Kubernetes. No, way before this, what we were doing is Ansible a lot to stack all these components that we needed to run Postgres in production. And what we realized, and again, from a programmer's background perspective, is that this Ansible code was not very reusable. I mean, yes, Ansible has modules and you can pass arguments and define blah, blah, blah. But the reality was that environments were wildly different. And so we were copying and pasting more than reusing code, infrastructure as code, because obviously we're doing everything through automation, right? And it was not reusable. It was an effort of copy and paste, which leads to code duplication. I mean, we all know the problems with that. So at some point I started reflecting on this, and it's like, how can we create a deployable package that is independent of the infrastructure? And I said, there's no answer for this. And then I started researching, and then I came to Kubernetes, and I was like, wow, actually, this seems to be an abstraction over the infrastructure. This is exactly what we need. And then we decided to do Stackgres. So the main reason is that it provides an abstraction over the infrastructure. Even more so, Kubernetes provides this concept of operators. And the operators are a sum of two components, CRDs, or custom resource definitions, and controllers. And this is the very powerful idea. So CRDs is the key. CRDs is, again, an API. So in Kubernetes, you have APIs. I call them objects. For me, it's an HTTP object server. Call me old school. And so if you want to create a pod, you just create a pod YAML or JSON, and you do a post to the API, and the pod will be created eventually, right? So it has its own set of objects that come with Kubernetes by default. But CRDs are basically, you can create your own object. You say the fields, the shape it has, the structure, you can use OpenAPI to define this later on and to validate it. And this is great for presenting users very high-level interfaces. In Stackgres, we support also sharding, which means scale out. We can create basically Aurora limitless in Stackgres, if I may say that. So you can create a cluster with 2 coordinators for high availability, 30 shards. Each shard is a cluster on its own with 1 primary and 1 replica, so it's 60-something nodes, and all wired up and connected with a technology for sharding called Citus. And this requires you around 13 lines of YAML.
Mm-hmm.
And all are super high level. Why
Mm-hmm.
is that? Because we can create an API through this custom resource definition, this CRD, and then the user only needs to interact with this.
Mm-hmm.
Now, the second part is the controller. The controller is, let's say, is a daemon. In our case, is a Java program that is running. And whenever the user interacts with these CRDs, that goes to Kubernetes. Kubernetes calls us back and say, hey, there's changes to this YAML, right? And if you want to do something with that, do something. And then Stackgres does something. And then translates this very high-level API, the CRD, into whatever components that Kubernetes understands, such as pods, services, persistent volumes, and so on and so forth, and then creates the Postgres stuff behind the scenes. So it's a very powerful model. And it's what
questions,
makes it
no question or observation. For me, the CRDs is just like not only, I mean, what they are really for me. So abstraction is like custom commands, right? So you can extend Kubernetes with your own behavior, and you're introducing basically command line commands which you can use. And what you can do, for instance, right now you can say Stackgres initiate or start, and the CRD knows what to do. No, which other commands behind the scenes has to be performed in order to do so, right?
Yeah, I mean, from a technical perspective, the command line will be a kubectl plugin,
mm-hmm.
and the kubectl plugin will essentially call the Kubernetes API.
Mm-hmm.
But in the Kubernetes API, you can also do a read or a modify or create a CRD.
Mm-hmm.
So yeah, it all boils down to the CRDs, however you interact with them.
Mm-hmm.
But yes, you put it very well. So it's a way to extend Kubernetes API because
mm-hmm.
you can create your own objects
mm-hmm.
right now.
Because I remember in what we did, and it was another product, so we actually also use CRDs, to start the cluster in right order. So so you can, if you have a stateful workloads, which is also similar to Stackgres, then you have to be careful which starts first and so forth. And I think with the CRDs, we had the power, also not CRDs, the operator knew how to do that, but the CRDs
Exactly.
were the API to the operator. So and I think if you have a CRD, you can automatically call it, right, from the command line. You know it. It was like back then. So there was without any. We just were able to, we define the CRDs first, and then we can use them or how to call it, trigger them via command line. Mm-hmm.
Yeah, I mean, absolutely, because it's just an API call away anyway.
Yeah, exactly.
So basically, once you have a CRD, you have effectively, if Kubernetes would be an HTTP object server,
mm-hmm.
you have created a new class.
Exactly.
And you can now do CRUD operations over that new class.
Exactly. And this is why, if you have an CLI, then you can interact with the endpoint, right?
Yeah. Exactly.
So another observation I have, it only works in your case because Kubernetes is already there. So it would be interesting if you would have to install Kubernetes first with all the PVCs and persistence, and then Stackgres on top of Kubernetes, whether it will still, the right choice to do. This is the interesting part, because you can say, okay, I only need Kubernetes, but someone else installs Kubernetes for you, right? Usually.
Mm-hmm. Yeah, it's a very interesting point, and actually it also comes down to what you were asking before, which is what would we do if Kubernetes will stop existing tomorrow, right?
Mm-hmm.
But first things first. So, because I said before that Kubernetes is this abstraction over the infrastructure, it makes a lot of things much simpler for us, right? And even though Stackgres is not a simple project, as of today, it's close to 250,000 lines of code. But still, it's much simpler than without Kubernetes. So Kubernetes, it's a complex system because it does solve complex problems, right? Distributed problems over computer storage and networking. So if I had to say, you're starting from zero, you also have VMs, you need to install Kubernetes, is it worth? I still think so. Actually, I've been very strongly opinionated. I have done a lot of talks. They're all linked on my personal page. And I say that by default, you should run databases on Kubernetes. So unless you have strong reasons not to, you should run database on Kubernetes. And that includes this use case. Like, okay, still, I don't have Kubernetes. Well, then you can install Kubernetes. Kubernetes There's two options to install Kubernetes. The preferred one for me, if you are running in a cloud service, is use a cloud managed Kubernetes
Mhm.
because it's quite inexpensive unless your cluster is tiny.
Mhm.
And managing Kubernetes, operating Kubernetes is not easy. It's it requires a bit of effort, right, and knowledge. And
Mhm.
operating it well can become hard. So if someone manages Kubernetes for you and you can aim for larger clusters, then it's a no-brainer for me. Just go for something like EKS, right? And
Mhm.
it just works.
Mhm.
Well, EKS in particular has a bit of things to improve with regards to user experience, but once we've dealt with that, the product is rock solid. If you're running on-prem, is it still worth to run Kubernetes? Well, the answer for me is still yes, but now you're going to need to pay that effort of maintaining Kubernetes. If it's for a small environment or even non-production environments, then absolutely, there is perfect Kubernetes distributions for those kind of environments. For example, on
Mhm.
my laptop, I run K3s,
Mhm.
and it's just one command away from installing Kubernetes cluster running on your laptop.
Mhm.
We haven't done it, but we have even considered packaging the Stackgres as AMIs or virtual machine images,
Mhm.
which just include Kubernetes.
Mhm.
So to make Kubernetes transparent to the user,
Mhm.
that is also a possibility.
It's interesting because I see this differently from my project perspective. So, what I see is that Kubernetes is absolute value on premise because there is nothing. And on premise, you get with Kubernetes a programmable API. Without Kubernetes, in smaller projects, we use Docker and Docker Compose. It works surprisingly well if you consider the project as an island. So we have so high available projects, which is really Docker Compose is 2 nodes, highly available, run for years, and no one cares, and it just runs. So if this is larger, it's impossible with Docker because IP addresses, whatever, is just impossible in
Yep.
larger network. So in the cloud, what I see is the projects. So if you're in the cloud, you're responsible usually for the infrastructure. So, and what I see Java developers are doing, so okay, we need Kubernetes because we need cloud, and they install in the cloud Kubernetes, spend some time on in the Kubernetes the application. I would say I will never do this because what I will do on AWS, let's say I will always prefer Fargate, for instance, for my
Mm-hmm.
applications or Lambda or whatever, and Kubernetes would be the very, very last choice. Having said that, if I would have to use, let's say, Postgres and with the offering, it has to run on Kubernetes. I mean, this is, but I wouldn't care about Kubernetes. I only see Stackgres as a program, like a
Yep.
product which runs somewhere, and behind Kubernetes also Linux, which I don't care, right? So, and I only interested in the Stackgres features or Confluent Kafka features, and whether they're running on Kubernetes or not, I absolutely don't care. So, and
Yep.
what he also said is that the larger companies are operating Kubernetes in the cloud. Okay, if they do so, then it's perfect. I was perfectly happy with OpenShift, because it was
Yep.
on premise, it was maintained and operated by another department. And I didn't care. I just push my Docker and it just worked with my application service, Quarkus, and whatever. But if I have to maintain it by myself, I will never pick Kubernetes because this is, heavy lifting, what they say,
It is.
undifferentiated heavy lifting. Why I should care about PVCs or whatever if the cloud, I have S3 and Lambda and everything goes. So this is the two perspective. And I see the companies, they try to pick one strategy for everything, which is not very smart. I would say for infrastructure, pick Kubernetes. For applications, it really depends what kind of application do you have. What I also observe is, for enterprise projects, serverless just shines. But if the enterprise projects are high traffic projects, then serverless becomes too expensive. And after few
Mm-hmm.
iterations, Kubernetes or maybe even EC2 blank EC2 could be the best possible option, right? So this is the flexibility I think we need today. And what I still see, the companies say, okay, Kubernetes is the strategy, then deploy Kubernetes and lose a lot of money because it is really hard. Do you have a huge cluster for the entire company, smaller clusters per teams, cluster per division? What about namespaces and stages? So this is harder in projects, but I would say simpler for infrastructure, yeah? Because you can say, okay, the database which was before don't think in a database, think in a cluster of databases, and you get the availability out of the box. And then I can still decide, I have isolated Stackgres for production, and maybe an int and def put together in isolated namespaces, whatever you have, right? So this would be the possibility.
Yeah, you touched on a lot of interesting points. One of them is that on-prem, there's no API. In the cloud, there's API. Whatever you use, there's an API, right? So you can automate and work on that and use infrastructure as code and pure code. In on-prem, there's no API. Sometimes you can argue that if you use something like VMware, then there's some APIs over there. But in reality, in general, there's no API. So using Kubernetes brings you an API, and that's great. So it does a lot of solve a lot of problems that you can solve with Kubernetes. In the cloud, there's many more options. So as you said, it could be the last choice in your case, and that's totally fine. But it also brings advantages. Once you are using something like Kubernetes, then you are essentially cloud agnostic. And this is important for some people. It's not for others, but it's for some. And then not only cloud agnostic, but also infrastructure agnostic. You can also move to on-prem or back or coordinate, right? So it also solves a different kind of problems. Where I see Kubernetes shine is for things like heavy microservices architectures, where you're deploying a lot of things independently and you don't want to be thinking where they are deployed and how to manage your high availability, how they connect to others. That's where Kubernetes actually can really shine. And you can, through consolidation of workloads, you could actually end up in a very cost-saving alternative, because it does bin packing of the container workloads you're running quite well, as long as you obviously define them also well in terms of resource consumption. And because of this model of operators, these CRDs and these controllers, I think that the model of controllers is extremely powerful. If you look at something like most infrastructure as code that exists as of today, thinking of Terraform and equivalent, they are day one only, or day zero, some people call it. It's just the deployment. I have automation to deploy stuff. But after that, what happens? What if something dies along the way? I mean, you're in the cloud, there's auto-scaling services and all that, but sometimes something breaks, something fails. And then there's no automation already for doing that. And there's no one watching. On the Kubernetes with the controller model, the controller is essentially someone who's, it's the code that you write as the operator, right? That every 10 seconds, whatever reconciliation period is, it's going to be watching that what you declared in your CRDs or, standard Kubernetes resources is going to be exactly what you have running in the cluster. And if not, it will take actions to correct that drift. And this is a very powerful model. You have someone watching for your infrastructure all the time. And that is the operators. And operators obviously have boomed as of lately, and there's operators for almost anything. So yeah, there's, as usual with anything, advantages and disadvantages. But I think it brings a very powerful model that gives you being cloud agnostic or infrastructure agnostic in general, which is a blessing on-prem, because there's nothing like API-based on-prem. And that with this operator model brings a lot of knowledge. And actually, like we do in Stackgres, we encapsulate huge amounts of knowledge of how to run Postgres into the operator itself, so that users don't need to deal with them.
Yeah, for Stackgres, this is unquestionable that it is the perfect choice. But I mean, in a project, really depends, especially, the two things. So Terraform, this is what companies are assuming, that Terraform is multi-cloud, which is not true at all. I mean, the syntax maybe a bit, but all the resources are completely different per cloud. Yeah. Also, what Terraform doesn't come with, what you touched on, is the state. You have to manage the state by yourself, which is really problematic, because at the beginning the state is checked somewhere with all the secrets, and no one knows that the secrets is actually really crucial. But the multi-cloud, right? So, for instance, in project, I'm not speaking about infrastructure rather than projects. We are using Quarkus usually in projects, and if you write Java code, this Java code, the same code can run on EC2, in Docker, or as a Lambda. So no modifications there. So and on AWS or in Azure, the same. I can run as Azure function. I can run in Kubernetes or Docker or app service, or on bare metal. So now the migration is a matter of surrounding the Java code with infrastructure. And so I will have to play with IAM roles. This is the or networks if I have to, the routing if I'm running private on Azure or AWS, and this is the major costs, not necessarily Kubernetes. And if I have to install Kubernetes by myself, I have two problems. Because first, on how it's called, Elastic Kubernetes,
EKS.
EKS, exactly, in Elastic Kubernetes, EKS.
Service,
I will have to run Terraform or CDK first to have the networking, and then run CDK for Kubernetes to have the Kubernetes, and then run actually my thing which deploys the Kubernetes, and the same for Azure. And my strategy would be then, put your Stackgres and on Kubernetes, and I would choose, for instance, pick on AWS Fargate, and on Azure App Service, not Kubernetes. And if I migrate, I can just migrating the Docker file, basically, and a container definition. And the infrastructure I will have to redo anyway, because it's completely different, IAM concept, identity, and permissions. So this is my observations. And in products, if we would build software as a service, maybe this is different, because we say, okay, we have a set of microservices. They are the same everywhere. And now we use Kubernetes as a packaging tool to migrate to all clouds. But and what you also said in controllers, you see large companies, they install basic Kubernetes, and they I don't think they will just replace the controller or do CRDs, whatever. They just misuse Kubernetes as EC2 machine, basically, what I observe. This is
but yeah, there are many cases like this, and obviously it's not always the solution for everything. But it's interesting. There's use cases where Kubernetes is used just because of these APIs, these CRDs. One example, I've seen cases where, for example, if you install the AWS I don't remember the name. It's like something like AWS and KAS at the same time. So it's basically it's a way of doing infrastructure as code by using Kubernetes CRDs. So basically, you can create CRDs to create EC2 instances or Lambda services or DynamoDB tables or whatnot, like what you would do with Terraform or CDK, except you do it in Kubernetes. So you need a Kubernetes cluster that will actually take these actions. And some people just use it for this. So just spin a small Kubernetes cluster, actually could be tiny cluster, just to use it because of the API and the capabilities of this. I'm not saying this is a good idea, but I've seen these cases, right?
I think this is a good idea, but you know what the difference is, maybe? There's a cloud like Hetzner. You heard about Hetzner, for instance?
Yeah, of course.
German. There's a very cheap cloud with a great hardware. So in this particular case, I trust Hetzner, to run the hardware well and is cheap. And now we use Kubernetes on top of it to standardize, because I wouldn't for instance, trust Hetzner to provide the same quality of serverless like how to call it, AWS, or the other one with not CloudFront, rather than the other, always confused. Cloudflare, exactly, or Cloudflare. And in this particular case, I will pick Kubernetes. But if I'm on AWS, before I play with Kubernetes and PVCs, I would talk to S3. You know what I mean? Because I say, okay, this S3 is a managed service, rock solid. And I would even say on AWS, maybe is Kubernetes less solid than Dynamo S3 or even Lambda, because they were before Kubernetes on AWS, right? So Kubernetes came afterwards. So I would say if I have an infrastructure cloud, just the or collocated machines, then Kubernetes is for me the way to go. If I'm on Azure or AWS, it really depends. It will say, okay, if this is a mature managed service, I will always pick the service. Otherwise, why I'm in the cloud in the first place, because I'm really happy on premise on OpenShift. So I'm a Java developer, and I was perfectly happy with private clouds. But if I go to the public cloud, my expectation is an improvement. And improvement is, forget about infrastructure and focus more on business logic, even more than on premise. And one thing is to pick Stackgres or Postgres, which is managed. For instance, I don't like to manage Postgres by myself in the cloud, never. So because I did it on premise, if I go to the cloud, I would like, that it is just, I would like to hit the endpoint and I'm done. And this is how I'm thinking the cloud in general, everything, I will pick CloudWatch before I create, my own log infrastructure, except it's so expensive, then we have to do this. This is always the same. If there is a monitoring solution, I will pick the monitoring solution of the cloud, except it doesn't work. So I wouldn't like to abstract from the cloud. I would like to use the cloud if I go to the cloud. So this is maybe
it really depends on the use cases. There's people who find using as much the cloud services as possible, and that's a very good idea. There's also people who cannot afford those costs. They normally come, the more managed services and the higher level they are, conceptually they cost more than the equivalent cost of the resources to run them. Obviously, there's exceptions to this rule. Lambda is a great one, but in general, some other people say no, I just want to have some environment where I can, for example, add nodes dynamically, and that's where the cloud shines. And you can have a Kubernetes cluster, and then if I need more nodes because I need to deploy more workloads, I want those nodes to be automatically created through auto-scaling groups and whatnot. And I just want a high quality networking and protection from denial of service attacks and S3 because why not, right? And then you can just lean on that and operate at a much lower price cost. So it really depends on the orgs and what their policies are and how they work. And definitely Kubernetes is not the only solution. Sometimes the solution is just to hide Kubernetes, like as we were talking before, right? Just deploy some EC2 instances, and then this is the service and it's exposed. In reality, is running Kubernetes and with all this on top. But I'm also lately, because there's still in the database world, more so than others, there's still some people. So there's kind of two camps, right? There's the camp who loves Kubernetes and will run database on Kubernetes all day, like I am. But there's also the camp who say, I will never run a database on Kubernetes. And there's no middle ground. There's no people who are so. It's just one or the other. So at some point, we started researching in our company, can we do something without Kubernetes? And this boils down to one of the questions you asked before. Okay, what if Kubernetes shuts down tomorrow? Well, even if it doesn't shut down, we also wanted to provide an answer to the question, can we do something similar without Kubernetes? And we actually are working on another solution that actually does this. So the idea is that, Kubernetes is a way to run containers. Let's put it that simple, right? And also can orchestrate. And what does it mean to orchestrate? Orchestrate means that it knows where to place those containers. It has a lot of algorithms that, depending on the resources that you need and the resources accrued across a cluster and whatnot, it decides where to run those containers. But at the end of the day, it goes to a node once it has orchestrated, once it has picked the node where things are going to run, talks to someone inside that node and say, hey, run this container here. That node, or that software that runs the container within the node, typically it's containerd, which is what powers most of the container runtimes today in the world. Docker is not Docker anymore. Docker is containerd. It's a shim layer over containerd. Technically speaking, what Kubernetes does is speaks an API called CRI, Container Runtime Interface, that containerd supports. There's also CRI-O, which also implements containerd, the Container Runtime Interface, and can also substitute. It doesn't matter. My point is that containerd is a programmable container runtime. And it has an API, which is called CRI. It also has its own API. So if you if you forget about the orchestration part, which is Kubernetes itself, and just pick containerd and the CRI API, and you program this API with a program, then now you can programmatically create containers on a node. So with this, you can create a pattern where you basically can run Kubernetes-like workloads without Kubernetes. Actually, we have created software for running this on Postgres, with Postgres. So create Postgres clusters with 0 dependencies. We bundle containerd as an embedded dependency. So you start from an empty VM, bare metal, just a Linux kernel, right? You install the tool. It runs containerd behind the scenes, hidden in a directory, will never conflict with anything else, and then programs containerd, download the images, and run Postgres. This becomes more imperative. Kubernetes is purely declarative, right? You just specify the intent. I want a cluster with 3 nodes being created. Here you need to go, hey, node A, run the primary. Hey, node B, join the cluster. And actually, some people prefer more in database world, definitely the imperative model. I'm more in the declarative camp, but still, I see the value. Sometimes you really want to say, I want this running on this node, right?
Mm-hmm.
And this is an interesting pattern also for those who are not into Kubernetes and prefer to go more on VMs. Postgres in particular, it's something that even though technically could run in other services, it's not really prepared to run on, let's say, Lambda or even Fargate, right? So Postgres is still stuck mostly to things like VMs or Kubernetes containers, anything like this.
So what you're saying, right? So you are exposing the containerd API, and you wrote software which configures via containerd. So this is the implementation, or not implementation, and reacts to containerd commands, right?
Yeah, pretty much. So containerd exposes two APIs. Its own API, let's call it proprietary to containerd, and the standard API that Kubernetes speaks, CRI. So we just program CRI. So we speak CRI. And it's because it's easier to use and higher level than the containerd proprietary API. And it speaks the same language as Kubernetes. So actually you can create pods. It's not containers, you create pods and you manage pods. So our software, what it does is embeds containerd. So it comes with the installation. The installation is a curl command, right? Curl pipe. SH. Obviously, there's also Ansible module. There's all the ways to install it. But once you have installed the tool, it also installs containerd and runs the daemon. Starts with systemd or I don't know which one also, but it doesn't matter. It starts the service, and you have a containerd, a private containerd running on a private directory. It doesn't conflict with your own containerd if you happen to run Docker, for example, the same node. It doesn't conflict. They don't talk to each other. And then we program this containerd instance through its socket. It uses a socket for communication, and call the APIs, and then create containers as we wish.
But you could also use Kubernetes for it, right? You could use the Kubernetes. So you could actually replace the Kubernetes pod with your pod, or how to call it.
Absolutely. But the goal here is to say, okay, some people don't want Kubernetes or cannot afford the complexity of Kubernetes, or just want to run in a more imperative way. Then here's the way. Actually, what I say is that this pattern is Kubernetes without Kubernetes, or Kubernetes pants. We took the lower half of Kubernetes.
Yeah, lower half. Exactly. But what I don't understand, you could also use the lower half of Kubernetes and have imperative API on top of that. You know what I mean? Because the controller talks to the pods via CRI as well, or containerd. And you could say, I don't care, then we remove the controller and we implement our own controller, which talks to the containerd. So why you had to package the containerd?
Because there's the assumption here, or what we want to make here, is that this works without any dependency. The main problem with Kubernetes is that, or in Stackgres, for me, it's a good thing that it runs on Kubernetes. For some people, this is a dependency that is not willing to be paid. Actually, we've talked with customers, in this case, on-prem customers, very large companies. And they say that, and I don't agree from a technical perspective, but they say we cannot run Kubernetes on our org because of the networking policies that we have. They go against Kubernetes networking mode.
Okay.
I don't agree with this. Kubernetes has a flexibility and plugins on networking. You can do almost anything you want. There's a lot of ways of doing networking Kubernetes. I doubt there's no single way that cannot be accommodate those policies. But that's what they say. That's it.
So what you did, so you provided the lower half of Kubernetes without Kubernetes. So it means you have less dependencies to Kubernetes itself. So you have just the containerd dependency and a cryo protocol implementation, which happens to be one curl command away. So shell, which you need in a private directory, and then you're independent. Which means, but we could still use Kubernetes operator to talk to your, how to call it, is not pod. What is it technically then? And stack pod or on pod, graph pod, and it means technically it could be possible that you run Kubernetes with your lower third with less dependencies, right?
It's interesting. It's just Kubernetes. It really depends how you see Kubernetes. So, well, first of all, what we have done does not depend on. I mean, technically depends on containerd, but we embed the containerd in a downloadable package. So you don't need to install it, right?
Yeah.
Now, if you look at Kubernetes, you may say, no, Kubernetes is a system that requires all these components, and splitting some components separately would be hard. Maybe. On some other way, people say, no, Kubernetes is a microservices architecture on itself. And, and there are certainly services talking to others. There's the API server, there's the kube proxies, there's the kubelets. This could be maybe kind of a replacement to the kubelet, for example.
Exactly.
Could be a way of saying so. It's something to be researched on, to be honest. But the idea that we did today is like, let's go for extreme simplicity, right? Someone just wants to run Postgres on an empty VM, the way you would do it traditionally by installing system packages, but without all the issues with installing system packages, and by running on containers, which has a lot of advantages on its own, and make it fully programmable. Right? This is the kind of the target we were looking for. And by the way, I need to give credits. This idea is not ours. This lower part of Kubernetes is not ours. It's actually what K3s did, this distribution of Kubernetes. Once I installed first time K3s, I was like, wow, this is just curl pipe shell, and I've got Kubernetes running on my computer. Didn't need to install anything. How does this work? Started researching, and this is what they do. They package Kubernetes as containers. It runs 5 or 6 or 7 containers. That is Kubernetes itself. The control plane, the API server, everything is containerized. And then downloads containerd, runs on a private directory, and then programs containerd to run these containers, which happen to run Kubernetes.
This reminds me of something different. Red Hat bought Linux distribution, which was highly modular. It was like OSGI, so it bootstrapped itself and then download the individual modules, and it disappeared. It became part of OpenShift, I even guess. I forgot if they had a cool name. So there was a Linux operating system, which was
about CoreOS.
I think so.
Yeah,
I think so. CoreOS, and it was it was bought by Red Hat in one point of time. And the idea was that they have modules which install dynamically on demand, like OSGI in Java we had back then.
Yeah.
And this is also a similar idea, right? So that you have small things which you can download. But what you did, you only had to do this to have Docker-like programmable interface, right? So this is what you wanted to achieve.
An API to run containers.
Yeah.
Exactly.
Okay. But if you would go to the kubelet way, so what you could offer is kubelet API without Kubernetes dependencies. This should be technically possible, right?
I think so. Yeah. Actually, once we have containerd, we could make small things. It's a great idea. Once we have our own private containerd, which comes embedded with the installation, right?
Yeah.
Then we could run the kubelet as a container.
Yeah.
The same way that K3s does.
Yeah.
And now, yes, we are a Kubernetes node, and then we could be managed by Kubernetes externally too.
Because then you can tell your clients and say, look, you can just, call us and do whatever you like, but we could also use, the Kubernetes reconciliation algorithm to keep us up to date, and we manage, the networking. So then you have the best of both worlds, I would say.
Yeah, sounds very interesting. Yeah. In reality, I see containerd as an extremely powerful software. By the way, it's very funny that containerd doesn't run containers either. It calls delegates running the containers to yet another program. So the kind of when you run a container with Docker, it's very funny because you have the Docker client to talk to the Docker daemon, the Docker daemon talks to containerd talks to typically Rancy or some other, but typically Rancy, and then it's Rancy who really runs the container for you. It's a long chain, but it kind of makes sense anyway. But it's really powerful. Containerd supports also the same plugins for networking and storage that Kubernetes supports, because that's what Kubernetes uses. And
but the history was that Docker was the product and the only product, and similar to Java, basically, it was just the Oracle Java, and then OpenJDK happened, and this was what there was Docker and Rocket, I think, right? Rocket without the E. I think it was the competitor of Docker, And Rocket standardized a lot of things, and then Docker was like the proprietary implementation, and they introduced the runc and the
Yeah.
OCI, I think, and this was the standardization process. And now the Docker is just another implementation, and this is why they had to do all the things. So they introduced all the standards, and before that, I think the first Kubernetes distribution were just Docker. They were depending on Docker.
Yes,
Yeah.
exactly. At the beginning, it was, yes.
Mm-hmm.
Yeah, but it's a very powerful piece of software, and I strongly believe in running mostly everything in containers. Has a lot of advantages, and this is just a programmable way of running containers.
And Rocket was RKT, RKT.
Yeah,
This
RKT,
was the
yes.
Yeah, exactly. This was
Yeah.
Rocket.
You're right. You're right. Yeah.
The container wars back then, and this is when the standards happened.
Yeah, and also Red Hat also had his own their own share of this when they created actually CRI. There was a lot of debate, and actually, if I'm not mistaken, OpenShift uses CRI-O instead of containerd, and crun instead of runc.
Now, Stackgres.
Yes.
So we committed to discuss a bit more. So what we already discussed a bit is Kubernetes, and what you said the last time. So you're also running the proxy, which manages the connections to improve the scalability per default of the connections. So it means what I get with Stackgres, I get Postgres cluster, right? Always.
Yes.
Or are you supporting just one instance of Postgres?
I mean, everything is a cluster. If you want to create it with one instance, so be it.
Okay. But usually it's more than one, right?
It usually is more than one. At least.
And what do you do then? Is this one leader and follower, or
yep.
Okay.
Primary and replica? Yeah.
Okay. And it uses the native the native Postgres protocol.
Yes, absolutely.
So what you could also do then, because you always do this, you can always offer CDC like the Debizium.
Very interesting. So let me elaborate on this.
We never finish.
Yeah, I know. But I hope it's interesting for the audience.
Yeah.
So in Stackgres, we have these CRDs, right? And the CRDs basically enable this high-level API. To create a cluster, CRD is pretty simple. You give it a name, and then you can say instances 1 or instances 2, and it will wire up everything for you, decide who is the primary and whatnot, the storage, etc. One CRD, we have also CRDs for what we call day 2 operations, CRDs that actually can do things like benchmark, database vacuums, minor version upgrades, major version upgrades. All that is automated. Just write a small YAML file, say, I want to do a minor version upgrade from this version to this version, and Stackgres will do everything for you. We created one that is called SG Stream. And SG Stream, what allows you is to stream CDC changes out of your Postgres database. And this is just a few lines of YAML away from running. So just say, okay, SG Stream, this is a source cluster. And if the source cluster is a Stackgres cluster, you just need to specify the name. And Stackgres will know how to connect, how to wire up, all the connection and everything. And then what you want to do with these events. Right now, we actually support publishing as cloud events, which is a standard for messaging in cloud native world. And then you can connect cloud events to anything you want, to Knative, to Kafka, to whatever you want. How this works? Well, we could have used Postgres' own logical replication built-in mechanisms, but then we need to transform them and adapt them as cloud events, etc. So what we did instead is use the Debizium.
Cool.
Now, the thing is that, the Debizium requires Kafka, and that would be also, even though we could automate all that, it would be not easy. So actually, we are using the Debizium embedded, which is the version of the Debizium that do not require persistence per se, and just runs as an embedded library. So we just embedded. It's basically a dependency on our Maven file. Stackgres, as I mentioned already, is written in Java. It uses Quarkus. It's a Quarkus application, and just uses the Debizium embedded. So it's thanks to the Debizium project, which is amazing, we're able to implement this without, I'm not saying zero effort, but it was very possible to do this.
Okay, so you can install with an operator. This is also one example for me, infrastructure as code with operators. There's nothing else than this, right? If you submit the YAML, I would like to have some streaming, and you install in background the embedded Debizium. This is an example where Kubernetes is used as infrastructure as code, right? Because this is what happens behind the scenes.
Yep.
And the embedded Debezium, what's cool about that is it is actually the one of the view ways where with a single transaction commit, you're writing to table and sending a message basically
Yep.
because
So
this is
the output is better.
the main advantage of logical replication on Postgres because you are in the transaction inside the transaction. Otherwise, you will always need two from the application. Like if I
Yep.
have Quarkus, which talks to Postgres and to Kafka at the same time, I need two-phase commit. But if I go to a table and you're doing this for me, in one transaction, I can actually write to table and send a message, which is impossible without this. So
Exactly.
this is actually interesting. So, where the cloud event is sent to. I mean, you have the embedded, and there's no persistence, but I need persistence, otherwise it's pointless. So what is the default? So what happens with the cloud event?
You need to define when you write the YAML file for the SG stream. You need to define what is the sync,
Okay,
and just write
yeah,
the sync.
it could be Kafka
Typically,
or could be whatever.
yeah, could be Kafka, could be Knative, could be something that you're also running on. Typically on your Kubernetes cluster, it doesn't have to. Anything it can connect to.
Okay. So what means is what is also a cool feature. What I learned right now is with YAMLs, which are you have lots of CRDs, day 2 CRDs you said, and
yeah, we call this
you can automate
SGDVOps.
and you can automate the entire cluster with the CRDs.
Yep, it's a very powerful mechanism because the CRDs have essentially two parts, right? The spec, which is where you declare your intent. It's purely declarative. So you declare your intent. I want a minor version upgrade to be performed, right? And then there's status field. And the status field is not user editable, but the operator does. And we actually abuse it to give back a lot of information.
Mm-hmm.
So let's say for example, let's look at the DBOps CRD that we have. It's used to it supports running benchmarks even for you. So on the spec part, you say, I want to run a benchmark with 10 threads for 10 minutes, whatever, specified parameters for the benchmark. Then Stackgres will run the benchmark for you, and we'll write the results back, the transactions per second, the duration of the test, whatnot, in the status field. So you can always go look at your CRD and set the results. They're just
okay.
It's a way of communicating to the user.
So with Stackgres, you get day 1 CRDs, which install the entire thing. You said this is usually 2. Can be 1. You have one of leader and a follower, which replicate with Postgres means, and you get the PG bouncer, right? Always.
Yes.
This is is also pre-configured. This is what you get with standard Stackgres installation. This is the out of the box.
Yeah, out of the box. The simplest cluster you can get will give you high availability. It's using a tool called Patroni behind the scenes for implementing Postgres high availability. It's not something built in. It comes with connection.
What it does, the Patroni? Is this like the operator on top of Kubernetes? Is like the Zalando operator, or what is it?
It's from Zalando, actually. It originated from Zalando.
Okay.
You're very well on point. But it's kind of a parent process to Postgres, which implements, actually talks to a distributed consensus store, a DCS, such as etcd or Consul. In the case of Kubernetes, it uses Kubernetes etcd via the Kubernetes API, so you don't need to install anything else. But it always uses a consistent distributed store, in this case, etcd that implements the RAF protocol, to have the view of who has to be the leader. So that if a node dies, Patroni would automatically detect this and will elect the new leader, connect to that node, promote it as a primary using Postgres commands, and then it also updates the services in Kubernetes. Stackgres will create a service for you, one for read-write workloads, one for read-only workloads, and will point them to the appropriate new nodes, reflecting the changes in the structure of the cluster.
So the Patroni is Kubernetes aware, right? So it knows Kubernetes.
It is Kubernetes aware, yes.
Okay, this was the missing link because I remember a few years ago, we looked at Postgres and Zalando operator for Kubernetes. And for me, the question was open, what happens if the cluster breaks? Because then I think there's no way, they had like a switch over policies, but I said, okay, what happens in between? That the transaction get lost. But this is now the job of the Patroni, to watch everything from outside and talk directly then to the Postgres nodes, right?
Yeah, so the way it works, Patroni internally, is that it's all the nodes should be posting all the time their log information to the
Mhm.
distributed consensus store, etcd Kubernetes in this case, and the leader also holds the log. And it needs to renew this log every amount of seconds. Typically, it's 10 seconds. You can configure this. And if at the end of a period the log is not released, it's not renewed, then it's lost. And then Petronic calls for an election, writes another key that are watching then all the nodes and say, hey guys, there's an election. Propose yourself if you want to, and let's do the one who has the minimum replication lag if you're running a synchronous replication. If you're on a synchronous replication, the same will happen, but then it's the most lag of those synchronous nodes will be 0. And then some nodes say, hey, it uses distributed consensus store to elect the new node, and then one will be the new node, and then updates the services metadata so that some labels basically, so that the services point to the right pod that is now the right read-write node.
Maybe you are too young, but do you remember Genie?
Genie?
Java Intelligent Network Infrastructure. This was actually what Java was huge, but what Genie had is a principle of leasing. And what it is, the interesting part is, like, Corba or whatever, the idea is I get a reference from you, proxy, and I call you. But in Genie, the reference was dynamic. So it means you had to lease. I had to lease the reference from you. And if you disappeared, you couldn't renew the lease. So it disappeared from my network, and I knew you walk away. So what I could do, I can register listener and I say, I'm leasing the reference to Alvaro, and if Alvaro disappears, I would like to be notified, and then I can create a new leader. And this reminds me, this was the Genie was 1999, so it was a long time ago. But they had such concepts, and they were actually great, but they were somehow forgotten because back then, Sun tried, I remember the use cases for Genie were printer drivers, and no one was interested in it. But this was actually, it was a great idea for microservices back then, way too early. And this lease renewal manager, this is what I remember. This was the name of the class. You can register, and actually, I had a short gig for a stock exchange in Portugal, where actually they also use heavily Genie. So Genie was actually big time, but interesting concept. This is what So, but back to Stackgres. This is way too interesting. so we have a Postgres cluster which manages itself, uses the Patroni from Zalando, which is interesting because they also had Zalando operator. This is what I used back then.
Zalando also has an operator. Yes.
Yeah, and you have PG Bouncer, and if I run, so this is what I get out of the box, and what interests me, what is the link to the Postgres? What I get? Do I get a DNS service name or how to call to the database? And what's also interesting, what happens in failover case? Does the DNS remains the same or how it works?
So you get if your application will run within Kubernetes. You will get a DNS name. If Kubernetes uses core DNS, and typically, and you'll get a DNS name, which is the name of the cluster that you gave in the spec, dot the namespace. So that's simple. So to connect to the application, just type name of the cluster dot name of the namespace, and that will connect. We provide 2 DNS names, one for read-write workloads and one for read-only workloads. In the case of a failover, by the way, the read-only ones, they're load balanced across all replicas. If in the event of a failover, then they will be updated once the failover finishes. So the DNS is stable always. You don't need to change anything from your
That is cool. And how long does it take, the DNS, flip over?
The DNS is actually quite fast normally because it's backed by etcd, and then it may have some TTL that depends on Kubernetes administrators how to configure it. The typical failover from Postgres perspective takes seconds. Sometimes it's as low as 5-10 seconds. Normally, I would say the median time is around 30 seconds.
Could you do something about it? You say, okay, what happens if I just keep writing, to the, are the transactions lost in the 30 seconds or?
So whenever failover occurs, at some point, if let's say the node you're writing to dies, right? So you will get some transactions. So first of all, you'll experience an error, right? And whatever it's midway through the transaction, that's not lost because it was never finished. It was never
Yeah,
committed,
exactly.
right? It will be rolled back. You will experience a rollback, and then the connection will fail. You will try to reconnect. If your application is programmed well, we'll try to reconnect. Will fail for now. Whatever you really wrote to the database was already committed back to you and say, yes, this has been durably written. Then it depends on how you choose the replication mechanism in Postgres, which you specify through the CRD. By default, it's asynchronous. And if it's asynchronous, you may lose data. Normally, replication in Postgres is very fast and has very low lag, below a second, right? So you may lose 1 second or 2 seconds of data if you're using asynchronous replication. If you choose to use synchronous or group replication, sometimes called semi-synchronous replication, which is basically majority, you will have zero data loss.
Okay.
So it really depends.
What it means from the application perspective, the DNS can be invalid for 30 seconds, but if it's valid, nothing gets lost. So this means and how long the DNS is invalid depends on Kubernetes TTLs and the DNS configuration. Exactly. Because I guess from the failover perspective, it is immediate. It is only the question how fast DNS exposes the changes, right?
No, failover is not immediate either, because so there's this compromise, right? Patroni actually holds the leader holds this leader lock. While the leader lock is not expired, the leader is still the leader, even though the leader may have died already. Now, once the leader expires because the leader is dead and cannot renew it, then it will call for an election. The election is also not immediate, may take a few seconds, typically less, and then promote the other one. This operation at Postgres level may take some time. Normally it's almost immediate. Sometimes may also take some time. And then it's a DNS changes afterwards.
Exactly. What I mean, the Patroni decisions are synchronous or almost propagated immediately to DNS. So
yes. Once
this is what I meant. Of course, the election until the lease expires, it takes everything time. But if Patroni decided this is the new leader and the leader is the leader, it is available immediately in DNS. But according to TTL or whatever, it can take additional 10 seconds or whatever.
Because the DNS is powered by etcd2.
Exactly.
In this regards, so they use the same source of truth.
Yeah, super cool. And is there a way to have 2 leaders?
No.
Okay.
Postgres doesn't support that architecture. I mean, let's say first answer, no. Postgres is primary replicas architecture. Now, there is some technologies in Postgres world, you can even actually do yourself, that if you use logical replication to replicate, you could have 2 leaders, and then they replicate to each other, cross replication, but then you enter a different world, which I'm not super big fan of, which is called conflict resolution.
Yeah, exactly.
Right. Conflict resolution,
like DSQL, what we did was a similar, situation where we had the chat last time.
Exactly. But DSQL doesn't do conflict resolution, because conflict resolution is a nice term for data loss. Like I'm gonna drop data. If there's
no matter the conflicts, also optimistic logging, right? It sounds great. And in my projects, okay, if you would really like to do this, what it means is we have a business decision in worst case. So we have two users who compete, for an insurance policy. Someone edits the policy and spends one time editing it. If it tries to write, what do you like to do? Someone else was faster. So what do you like to do? Should they one win? Should they first win? Or someone has to merge? This is the resolution. And merging never happens because it's way too complex. And usually the last wins. Some work is lost, which can be really costly. And this is why in most business processes, they are built this way, that such a thing doesn't happen. It means we have pessimistic logs on the business level, and the database does whatever the database does, because it is really hard to justify if the business people understand that the work can be lost. They have zero tolerance usually. This is
exactly. Yeah, the typical human-based operations tend to work better with pessimistic logging than optimistic logging. So in Postgres, the straight answer is no. Then the next answer is you can use logical replication, but then you're subject to conflict resolution, which is not nice. And then there's a third option, which is if you can divide your data into subsets, you can shard your data. So if you can do sharding, then yes, because each shard, it's a cluster on its own. And again, this is something that we support in Stackgres, is We use a technology which is an extension in the Postgres ecosystem called Citus.
Mhm.
And Citus allows you to do queries to a coordinator node, and then it will spread out the queries to the appropriate nodes, gather the data, bring it back to you. So it behaves like a single database. In
Mhm.
reality, there's a lot of databases, and we have created CRDs that make this trivially simple to create these sharded clusters. And now you have a lot of primaries, only one primary per subset of the data, but you have a lot of subsets of the data. And the advantage for this, apart from obviously scaling writes as much as you want technically, is that if any cluster fails badly, like gets destroyed completely, all the nodes, right? It just goes down, then only a percentage of your users go down.
Yeah.
If you architected your application accordingly.
And can I shard according to the primary key, right?
Sorry?
Can I shard?
Yeah. You decide, actually, with Citus, you decide when you basically you create a normal table, and then you call a function called create distributed table, and then you specify which are the column or columns that are the distribution.
So what you get with Ongress with that is similar architecture to DynamoDB.
Very similar.
So
actually, I did a talk about can Postgres scale like DynamoDB.
Sure.
Very heavily about sharding.
So you have to restrict to 10 gigs. The only challenge would be to resharding, right? If you hit the hot partition, you will have to do it dynamically. If you can, it would be very, very similar.
Which can be done with logical replication, but it's far from trivial.
Pretty cool. Have we covered at least the Stackgres a little bit, or still it's just 5%?
It's 5%, but I think we've covered a few topics. I could just mention one thing that I think could be interesting if someone wants to try it, which is that it allows you to operate in multiple different ways. So the standard, let's say, Kubernetes way is the CRDs that we have talked broadly today about. So the YAML files or JSON files, and then you call Kubernetes or via the API. That's one way. Stackgres also exposes in its own, let's say, proprietary to Stackgres REST API. So if instead of dealing with YAMLs, you prefer to call an API, you can also do that and manage absolutely everything. And whatever you do via the API will be reflected on the CRDs and vice versa. And on top of that, it also comes with a fully featured web console, which is a very unique feature of a Stackgres. I'm a super command line person, but I use the web console a lot because it's so convenient, right? And it operates the same way. Anything you do on the web console, you can see from the REST API, you can see from the CRDs. And so the web console is very human friendly. The REST API is meant for integrations. If you want to use Stackgres as a backend for your own service or tool or whatever, you would typically use the REST API. And if you want to do more Kubernetes standard way, you use the CRD. So you can interact in any way. And I think that's also make it quite unique.
One thing which interests me a lot, but I didn't ask any question in this direction because it would explode, is why you use Java and Quarkus for the entire thing. So which means I have to reinvite you back just to talk about that. So I just wanted to cover once, Stackgres a little bit and managed to do it somehow. And the next thing is, of course, would be also my choice, but why you did it. So the next time we have to talk about Quarkus and how you managed Kubernetes with Quarkus, why you do this, whether you are happy. And maybe the containerd thing is also interesting. What they are doing, the dynamic container provisioning, that were two, if you like, two things.
With pleasure.
Yeah. And because if I talk with you, I get two ideas for a sentence. So I have to be really very cautious about the agenda. Otherwise, we will never finish. So, thank you. And where people can find you. So you have a nice acronym, what I learned already. So where I can find you?
I think the easiest way is through my personal webpage, which also already links to the social media accounts. And it's so simple. It's just only 5 characters. Well, 6 including the dot. So it's AHT, as in Alpha Hotel Tango, .es, Echo Sierra, or like Spain, the TLD, right? So AHT.es.
Yeah, and today we talk about Stackgres, which is available via website, and Ongress is your company, right?
Yes, Stackgres is stackgres.io, and ongress.com.
And Stackgres is the main product?
Yeah, exactly.
Okay. Yeah, cool. Thank you. And see you next time.
Indeed. Thank you very much.
We have to wait until it uploads.